Hi everyone, let's begin one more new session with Gretl for econometrics. And in this session, we will understand how we can check normality test of our data. Because that's the most important step. We have to decide test accordingly whether is our data is normally distributed or it is not normally distributed. So first we will understand normally distribution, how we can check. So for this purpose, let me show you, this is the Gretl interface. First of all, open a file, open data. Sample file I'm going to open. First one file, this file I had opened. Let's say I want to check, this one is the industry output, right? Let's say I want to check whether this data is normally distributed or not. I will select this, select variable, then normality test. I will press this normality test. Now these are the outputs. And simply what we have to do, we can copy and simply we will paste it in my PPT. And now we can see, I think I had already pasted on my PPT. Yes, these are the results. And it will ask you copy as RTF or plain text. You will say plain text. Okay. So simply that is, we will paste it here. Text of normality of industry output here. So there is 4 kind of test is here. You can see Dornick-Hansen test, shapiro test, Lillyford test, and jarqubera test. And one by one, we will interpret all these test output. So we will paste it here. Now we can see I had pasted here test for normality of industry output, right? These all 4 tests you can see here. I think this one, it is twice, it is pasted here. So I'm just removing this. So first here in this example, Shapiro test, now W value of W is 0.9529 and p value is 1.15 e to the power 0.17. What is the meaning of this? So W test statistics 0.95, but p value, how we can interpret this value. So what is the meaning of this? Now you can see here. We can count number of zero. We can count number of zeros also. These are to the power 17. So means this decimal after 17 zeros, 0.00000, this is the interpretation of this particular value. Then what we have to do, what is the purpose of this test? Shapiro test, why we are using? The most important question. So purpose of this test, to test if the data comes from a normal distribution or not. So we had created 2 hypotheses. One is the null hypothesis, another one is alternate hypothesis. Null hypothesis, it's saying the data is normally distributed, and alternative hypothesis is saying data, it is not normally distributed. So analysis, how we are going to interpret, analyze this term. The W value 0.95 is fairly close to 1, suggesting a moderate fit to normality. However, the p value is extremely small, that is much less than 0.05. Now we can see here, that is this value, that is much less than 0.05. So what we have to do here is, there is strong statistical evidence to reject the null hypothesis. So we can say our data, it is not normally distributed, means alternate hypothesis is accepted. The data is not normally distributed and null hypothesis rejected. The data is normally distributed. So null hypothesis is rejected. Then how we have to write the conclusion? Conclusion is the data is not normally distributed despite our relatively high W value. The result might indicate a subtle but statistically significant deviation from normality, possibly it may be possibility due to large sample size which makes small deviation detectable because sample size is large. So just because of this. So consider visual checks like histogram or QQ plot or use non-parametric tests if your analysis requires normality. Right. Then we will move to the one more. Now here it is. I am just showing you how I have to perform this test. I will go to employee, right? UK employment in company. I will show you this how this data is looks like. Now you can see this data is like that. You can see this data is like that. So simply I will select this and what I will do, go to variable and normality test. Select this normality test. Again, I will copy and paste, right? Copy. A moment I will select copy, it would ask you copy as RTF, WS Word, sorry, MS Word or plain text. I will say plain text. Okay. And I will paste it here, right? So I have already pasted here and once more I will pasting here. So now you can see I'm just pasting here. So now you can compare both these datas are same or not. So I had pasted a test of normality of employees. So all these four tests I had pasted and now you can compare what I had pasted earlier. So both are same. So I am just deleting this upper one part and I will show you interpretation of this one by one. So test for normality of employees. First is what is talking about Dornick-Hansen test. So value of this 7951.57 with p-value 0. So Dornick-Hansen test is a statistical test for multivariate normality. This is the extension of normality test to more than one variable. This test actually it is working when normality we are checking normality test to more than one variable and you can see here in my data set what I am checking. There's the n number of the variables. Like you can see employee wages, gross capital, industry output and their log values after that we have taken. So these are the number of the variables. So it is talking about the Dornick-Hansen test is a statistical test for multivariate normality and extension of the normality testing to more than one variable. Now test output, we can see test output, it is visible here. Let me just, I'm using another font size, another font color, red. So now Dornick-Hansen test, these are the values, 7951.57 and p-value 0. How we can interpret this? Interpretation is same. Null hypothesis, the data follows a multivariate normal distribution, but alternate hypothesis said the data does not follow a multivariate normal distribution. So p-value that is in this case less than 0.05. That indicates strong evidence against multivariate normality. So there is no multivariate normal distribution. How we can conclude it? Since the p-value is 0, we can reject the null hypothesis. It means the multivariate data is not normally distributed, right? So what we have to do here it is the result supports what the Shapiro test indicates earlier. For univariate data, your data set does not satisfy normality assumptions and statistical models or tests that assume normality like linear regression, MANOVA, etc. may not be appropriate without transformation or robust alternatives. Then Shapiro will test, I had already explained you for previous variable and that is same here, right? In this case also, in case of the employee also, right? We can see here. Shapiro will test, that was the second output we have received. So I'm just highlighting this again. 9.8 and in all these things, it's to the power 048. So now here is how we are going to interpret that is reflecting here. And Shapiro will test. You can see here how you are going to interpret this. These are the 48, right? Decimal point after decimal point 48 values you have received. So W it is 0.472 is the Shapiro will test and P value 9.848884 to the power 48. So now interpretation is the null hypothesis of the Shapiro will test is that the data follows a normal distribution, right? The alternative hypothesis is does not follow a normal distribution and p-value that is against the null hypothesis. It is supporting alternate hypothesis. Then since p-value is extremely small, essentially zero, you reject the null hypothesis. This means the data is column 2 is not normally distributed, right? So now what we have to do, third test, we will move to the third test, third output that we have received in the normality test. Let me change color of this particular. This one is the Lilly force test and we will go back to the Lilly force test. Third one is Lilly force test. Same values, right? And the Lilly 4 test is a variation of Kolmogorov. This one is the Simonov test, specifically adapted to test whether the data set follows a normal distribution when the mean and standard deviation are estimated from the sample rather than known in advance. So I have already prepared a video on normality test in my SPSS playlist. I would show you the same data, same Word document here also. You can refer this Word document. I had already explained long back in my SPSS playlist. You can refer this. And here it is. I had explained normality test with the help of all these kind of tests. And what we were talking about, it is talking about Kolmogorov. Let me highlight this Kolmogorov. This one is the test and it is that is through this is the SPSS output. But when we are going to compare Gretl, this is the test means Lilly force test. It is equivalent to Kolmogorov test of SPSS. So specifically adapted to test whether a data set follows a normal distribution when the mean and standard deviation are estimated from the sample. So Lilly for statistics, we have received this means same null hypothesis data is normally distributed, alternate hypothesis data is not normally distributed, very small p-value, it is the evidence against normality. So conclusion, what we have to do, how we are going to conclude it, here it is since the p-value is effectively zero, you reject the null hypothesis, therefore your data does not follow a normal distribution. So that confirms your Shapiro-Wilk test, right? Nornick-Hansen test already showed non-normality in the data set. That is also supporting the same. Now we come to the last test. Last it is we have received 4 outputs through Gretl. This is the beauty of the Gretl. It is giving at a time all these 4 tests of the normality and how you are going to interpret all 4 tests. So now we come to the last one. It is jarqubera test and value of this 14296.8 with p-value is 0. So how we can interpret, right? So first of all, where we are going to apply jarqubera test and what is this? So jarqubera test that assess whether the sample data has the skewness and kurtosis matching a normal distribution. So null hypothesis, it said data is normally distributed if your skewness is equal to 0 or nearby 0 or kurtosis it is equal to 3. But alternative hypothesis said data is not normally distributed, right? When we are violating this assumption. So here it is interpretation of your results. High JB statistics for 14296.8 and p-value 0 indicate a strong violation of normality. And since p-value it is less than 0.05, we reject the null hypothesis. The data is not normally distributed. It is likely skewed or has excess kurtosis, that is more than peaked or flat-tailed than a normal distribution. So summary it is that this one is the all four test conclusion. Shapiro-Wilk test, right? Not normal. There is the Durnik-Hansen test, not normal. Then the Lilly-Force test, that is also not normal. And jarqubera test, that is also not normal. So all four tests, that is all tests strongly reject the normality. And similarly, I would show you the same file I had uploaded when I had a recorded video through SPSS. That was the normality test. This Word document is also uploaded over there. It's applicable only on. So I had given all the conditions how you have to check the normality. So skewness and kurtosis, Shapiro test, Vox plot, PP plot, QQ plot, all those things I had mentioned there. So means I said mean equal to median equal to mode. If this the condition means your data is normally distributed. Correct. Then we come to the further it is Kolmogorov and Shapiro-Wilk test I had explained here. And similarly, I said here in this skewness and kurtosis, that is the same way I had explained here through jarqubera test. It is the alternate of this particular test, right? Skewness and kurtosis. And this one is we will talk about this is the alternate of Lilly-Force. It is the alternate Kolmogorov test. Right. And this one is the for the Shapiro-Wilk test, that is the whether your data set is normally distributed or not. But when we will talk about Durnik-Hansen statistic, that is multivariate normality, means in the presence of more than one variable, it is tested. So I hope this video would be helpful to you. Stay tuned and keep watching. We are covering some more points in the coming up videos.